Okay, so we are going to talk about domain and range for continuous graphs, not just points on a graph. So for domain, you're going to scan your pencil from left to right along the x-axis. For range, you're going to scan your pencil up to down along the y-axis. So really what we're going to look for is we're going to be building walls left and right for domain, and we're going to be building floors and ceilings for our range. Now before we begin, I must tell you that this is one of the harder concepts to get across. So it's going to take some time, and it's not too hard. It just might take a little bit of time to get this. All right, so let's start for number 1. Can we build any walls on number 1 if we see to the left, this arrow goes all the way over here, and to the right, this arrow goes all the way over here? Are we going to really build any walls? Well, not really, because you can only build a wall if something doesn't go on forever. So in this case, our domain is not restricted. It's everything. It's every little number in between, because here we have -1.5. Here we have 3.2. So all of those decimals are included in our domain. So we don't just, list, -1 to -5. No, it's every single number, all the way from -infinity to infinity. So for our domain, we're going to write all real numbers, because it's every single number. We don't have any restriction there. Now we're going to look at our range. Our range goes from bottom to top. Can we build any ceiling if our range here, if our arrows are going to go forever and ever and ever on upward? Well, no, you can't build a ceiling for that. But we see here we can build a floor. So here's our floor. What is the lowest point for our floor? Well, it's this point right here, and that's -2. And we got to think, how would we compare all of these values of my graph here? How would we compare those values to -2? Well, like this is 4, this value is 1, this value is 3, this value is 0. All of these numbers are greater than -2. And if we look very closely, we see that it actually reaches -2. So we want to say that our range are all of our y values greater than or equal to -2. And that would be our range. Let's look close at our circle here, number 2. Now obviously this is not a function. It does not pass the vertical line test. But we can still describe the domain and range. And so if we look here, can I build any walls? Can I build any walls here? Well, yes, you can. We actually have 2 walls. So we have what's called a double restriction. We have a lower number and a higher number. So here we have -3. The numbers on the inside, we have -1, +1, 2. You notice these numbers are greater than -3, but they're smaller than +3. So when we go to write the domain, we actually are going to have a double inequality. It's called it's like a compound sentence in English, okay? It's going to be double inequality, and I always put the smallest number on the left and the biggest number on the right. Okay, our values for x are greater than -3, but they're also touching -3, so I need to have the or equal to. But all these numbers are also less than +3. Again, it's also touching +3. So this is the way we'd write our domain. We'd say x is bigger than or equal to -3 and less than or equal to +3. Now let's look at our range. Our range has a floor here and a ceiling there. And if we look at our numbers here, we see, we also are at -3 to +3, and again, everything in between there. So our range is almost exactly like our domain, with the exception we need to have a y in the middle. Okay. So go ahead and try to make your floors and ceilings and do the best you can on 3, 4, 5, and 6. And then go ahead and hit play. And we'll go over the answers. Okay, number 3, no walls or ceilings. Our line goes forever to the left, and it goes forever to the right here. So this would be all real numbers. I'm just going to abbreviate. Range also goes forever up and down, so that's also all real numbers. Okay, number 4, our domain is going to go forever to the left and forever to the right. No walls, all real numbers. And our range has a ceiling here, and it goes down. Here it's going to keep going down. And if we look at our numbers here, so -3, -1, and our highest number here is 4, and it does reach the 4. So all these numbers are smaller than or equal to +4. Okay, let's take a look at number 5 here. So number 5, we look at our domain, and our domain goes from -1 to +5 here. And so this is going to be one of those double ones because there's 2 restrictions, one on the left and one on the right. So we have -1 and we have +5. And if we look at these numbers here, x is greater than or equal to -1. It does touch at -1. And it's less than or equal to +5 because it does touch. If we look at the range, we have our range goes from, let's see, -3, less than or equal to, and then +3. So it's kind of like number 2 there. Okay, number 6. If we look closely at number 6, first off, we can see that there are no walls. It's going to go forever to the left and right. So that is all real numbers. A common mistake is that people think that, oh, I have a floor and a ceiling here, but if we look, our graph extends lower than this, and it goes above this. So actually, we have no floor or ceiling. This is a mistake here. We don't have this here. So, whoopsies, don't want to do that. All right, that's okay. So we actually don't have any floors or ceilings here, and this would be all real numbers as well. So all real numbers. Okay, all right, so number 7 here, again, we have domain left and right. So it's going to go forever left, and it's going to go forever to the right. So that's all real numbers. Now, if we look at the pattern of our graph, our pattern is up, down, up, down, up, down. So algebra is all about patterns. So I'm going to go ahead and assume that this is going to be my pattern forever. And so my range is going to have a floor and a ceiling here. And so it's going to go from -3 all the way to +2. All right, if we look at number 8, let's look at our domain. Our domain goes forever to the right, but we do have a wall right here. So there's only one restriction in our domain. So it's not a double inequality. I'm just going to compare it to -1. So x compares to -1, and if I look, all of these numbers are greater than or equal to -1. So that's my domain. My range goes forever down and forever up. So there is no ceiling or floor. So that's all real numbers. And then if we look at number 9, we just have a vertical line here. So our domain is actually going to stay. It doesn't go left or right here. So our domain is x equals 2. It doesn't go left or right. Our range, however, goes forever up and down. So that's all real numbers. Okay, and here we have a horizontal line, which our horizontal line goes forever left and right. So that's going to be all real numbers. And it does not go left or up or down from this point right here. So y is just equal to -4 because it stays at -4 the whole time. So this is going to take some time. I'm sure many of you have questions, and that's okay to have questions. We're going to be doing this the next class and then the class after that. So do not worry, we have time to really get this concept down. But for right now, I just want you to try. Just try your best. You're going to make mistakes, and that's okay. That's expected. All right?